All right, you guys, here we go. We're doing the second part where the standard deviation is unknown. So this is the t distribution, not the z distribution. Okay, so we randomly select 36 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership's lot before it was sold. The sample mean is 9.75 days, so that's my X bar right there, with the sample standard deviation S of 2.39. Here they want us to construct a 99% confidence interval for the population mean of the number of days the car model sits on the dealership's lot. Okay, so because we don't know this, the population standard deviation, and they told us that the sample is random, and since 36 is larger than or equal to 30, we can go ahead and use the t distribution. It's going to give us a normal distribution. So with a 99% confidence and my degrees of freedom of 35, because it's always one less than the sample size, so 36 minus 1, our t-score, so if we go down our t-distribution to 35 and go across the top to 99%, you'll find your t-score is 2.724, okay? All right, so here's our margin of error. We just plug all that in and we get about 1.09, okay? So a 99% confidence interval becomes our sample mean plus or minus the margin of error, okay? So we do that, plug it in, and we get, there's our sample mean. So let's interpret that result right there. So with a 99% confidence, we can say that the population mean, number of days the car model sits on the dealership lot, is somewhere between 8.66 days and 10.84 days. All right, so in a graphing calculator, so we can go choose stats, you guys. So the stat button on your graphing calculator, scroll over to tests, and then select statistics, and then plug in all the info. Okay, so you're going to plug in your mean, you're going to plug in your sample standard deviation, and then your 99% confidence interval. So then you then select calculate, and we get this right here in our calculator, and which is close to this. This is just rounded right there. So here's our interpretation. 99% confidence. Well, it's the same right there. But that's how you do it in your graphing calculator. Okay. All right. So when constructing a confidence interval, is your population standard deviation known? If it is known, then if either the population is normally distributed or your sample size is greater than or equal to 30, then we can use the standard normal distribution of your z-scores. And then this would be my margin of error, my z-score, my population standard deviation divided by the square root of n. This is the same thing, except it's a t-score distribution when it's not known. So either the population is normally distributed or n is greater than or equal to 30, then we use the t distribution, okay, where there's the margin of error. Don't forget your degrees of freedom is always your sample size minus 1, okay? All right, if you guys are in my class, that would be your assignment. Take care.